I'm going to open this as if I was just starting this project. So we go to Blackboard and we go to our class, we go to our course content, and we go to week 3. And I just wanted to mention actually this, so it's good I did this way. So here's the project. When you click on the introduction to project, it takes you to the discussion board. So there is already some people asking questions. So there is already a conversation going. So if you didn't read it, take a look at it. Maybe it will clarify some things for you. So that's the discussion board. It's optional, so you don't get graded on it. So that's good, right? We don't have to stress about it. But let me go back to, so here are the instructions. And this is what it is. So first, it tells us identify variables according to their data types. And this is important because you already learned about, sometimes we use histograms, sometimes we use bar charts to represent this. So I don't know if you remember, do you know what we use for what? Numerical and categorical, like one is histogram and one is bar graphs. Do you remember which one is which? If you don't, that's okay. I'm going to illustrate it later. But numerical, because it's a continuous scale, it's a good idea to have it as histogram, because then you see the columns are not separated and you see the continuity of your scale. So with that being said, there are I believe 3 numerical variables. So you'll have to answer question number 2 with histograms, and it spells it out for you actually, right? Use histogram. So, and it tells you to calculate the minimum, maximum, mean, mode, and standard deviation. So this is what I want to talk about first, because I don't know if you know how to do this. Do you guys know how to do this very quickly on Excel?
No.
No, I do not.
Okay, awesome. So I'm going to help you with that, because this, you shouldn't be doing this manually. This is why we have statistical softwares. Excel is not a really statistical software, right? It's more like an office tool, but we could do a lot of statistics with it. So this is what we are going to do. I'm going to scroll down to the bottom of this. Patient ID is just individuals, right? That's not a variable, so we don't have to worry about that. But for example, age, that's, what is that, numerical or categorical variable?
Categorical?
No, numerical, right? It's numbers. So for numerical variables, we are going to calculate all of those statistics, mean, minimum value, right? It would make sense. For categories, is it a smoker or is it not smoker? Average does not make sense, so that's why we would not do that. So I'm going to show you how to quickly do that. So for example, if I want to do minimum value, look, it's already telling me, oh, what do you want to sum it up? No, I don't want to sum it up, but I want to get, for example, minimum. So I start writing minimum and it's already hinting me, oh, do you want to find minimum value of numerical data set? So Excel works the same way. It also does this for you. The only important thing that you have to remember is, so Excel knows what you want is put that equal sign in, because then it starts guessing that you want a formula for something. So you put the equal sign and you do min. And so you don't have to start sorting everything, right? You're just going to select your data. It's 300 values, so it's not too bad, but there is a quicker way of doing it. But I just want to make it the simplest way possible, right? This is oral values for ages. Somebody's 50 years old, somebody 45 years old. So that's what we have. I just hit enter right now. And there it is. The minimum, the youngest person was 40 years old. That patient that was 40 was the youngest person. So I could do the same thing with the maximum. So what do you remember what I put first? How do I start formulas? Yes, equals. And I start writing, okay, I want the maximum value. So who is our oldest person? I put MAX and it's already hinting me, okay, you want probably the maximum. It spells it out for me. Maximum value in a numerical data set, right? You see, numerical data set. It would not give it to you if it was not numerical. It would give it to you for those zeros and ones because that looks like numbers to Excel and Google Sheets, but you know, hopefully you understand the difference. So I could also, instead of selecting it and scrolling up and down, I could just say B2 colon B, and my last value is 300. And I hit enter, and there it is. My oldest person is 95 years old. I could also do the average or mean, right? It's the same thing. So if you try mean, it doesn't recognize it. It recognizes it as average. So that's a little bit, you know, something that you have to remember. Same thing for Excel. It's exactly same thing. Average, and I'm going to just write down B2 column B300, and it's gonna give me that on average, these patients were about 61 years old. What else? Oh, the standard deviation. If you had to do standard deviation by hand, it would take forever. You don't want to do it by hand. You need to use Excel or Google Sheets. So I'm going to put equals, and I'm going to start writing standard deviation. So ST, and there it is. Look at that, standard deviation. If you look at those options, there is something a little bit confusing because there is also standard deviation of an entire population. There's also standard deviation of a sample. So since this one is not specified, you would probably be guessing, is this which one is it gonna give me? You could just choose this one. If you do choose this one, it's giving you the sample. So it's okay to choose the first one, but I'm just going to do it properly. I'm gonna say, oh, this is for a sample. My data is a sample. There's different formulas. I don't know if you remember, but there's different formulas for standard deviation of an entire population or of a sample, in our case, 300 people. So I'm going to again choose B2. I don't know if you both got to standard deviation calculations yet. Maybe not, maybe not.
No, not yet.
Okay, so, you know, this is how your data is spread out. Now everybody is 60 plus 11 plus 12 years old, right? So 72 60 minus 12 is 48. So 48 to 72, a lot of people is in that group. So the standard deviation tells you about the spread of the data, how wide your data is. Okay, we didn't do the mode and we didn't do the variance. Same thing, same exact thing.